Module 8, Lesson 2 continues our study of intersecting lines and the angles that come from them. This time we're going into complementary and supplementary angles. If you take a look at the suggested pacing, they're claiming this is going to be a 2-day lesson, has 17 resources, so that's a fairly real prediction, I think. Have you ever driven over a bridge where a sign stated that there is a weight limit? Did you wonder how the weight limit was decided? When engineers construct bridges, they need to take into account the load or weights that will travel across a bridge. Differences in the angle measurements that are used in the bridge's design and construction can change the load that that bridge is going to be able to support. To locate a pair of angles in a truss bridge that form right angles, what is the sum of the measures of the two angles? So if you take this right angle and that right angle, you add these two up, you make a straight line, which is going to be, of course, 180 degrees. Let's keep moving here. Our inquiry question asks, what does it mean for an angle to be complementary or supplementary? Well, let's see what they have to say. Press Show Measure of Angle ABC button and make a conjecture about the sum of the measures. So we're going to show that angle, and that is going to be, no, I see what they say. I pushed the wrong button. No. Measure of angle ABC, that's A, B, and C, and these angles combined are going to be able to form a 90-degree or right angle that you can see there. And then make a conjecture about what happens when you add ABD and ACBD together. Yep, you add these two together, you get 90 degrees. It makes a right angle. Now, I think we're going to do the same thing, only now we're going to do it for the bigger angle, where we're taking and looking at, since the angles ABC and CBD are complementary angles, that's your vocab term right there. Anytime you have two angles who come together to equal 90 degrees, they're going to be defined as complementary angles. From here, they're also going to be looking at supplementary angles, where now we're going to take and show the measures of angle A, let's see here, BCD, that's this one here, and angles DCA, that's this one here. And what do you get when you add those two angles together? You're going to get a straight line, and a straight line is a measure of 180 degrees. And these are what we know as supplementary angles. Let's see, do they have a definition there? Yep, we'll probably find that in the next set of slides. And here's our first official definition. The definition is complementary angles. Two angles are complementary angles if their sum is equal to 90 degrees. I'm going to go ahead and highlight that in words. Measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. And you notice this little red square they have here in the corner? That tells you it is a right angle. And of course, all right angles are going to be 90 degrees. Moving on to symbols, we could say that the measure of angle 1 plus the measure of angle 2 equals 90 degrees, and that would be a formula you would use to solve the measure, to find the missing angle of either one of these 2 points. Moving forward to example 1, where it's going to tell us that, give the measure of the angle that is a complementary to the given angle. So we have one angle that's equal to 60 degrees, and we want to know 60 plus what number is equal to 90? Well, that's obviously going to be 30, but we've got to be able to use big kid math to find it. So using that big kid math, we're going to take and say, what is the sum of the two measured complementary angles? That's going to be 90. So when you add them together, you get 90 degrees. From there, the equation is going to be 60 plus x is equal to 90. That's going to be our formula for solving it. And then we're going to solve for x. And when you solve for x, you do need to show the big kid supporting work where you subtract 60 on both sides in order to find out that x was going to equal to 30. And so this is the measure of the missing angle. It's going to be 30 degrees. From here, we're going to go straight into extra example 1. You're going to work this one. Make sure that when you're isolating the variables, you're giving me good quality supporting work doing it. So the angle they've given us is 75-degree angle, and we need to know what we can add to that to get it to equal to 90 degrees, and we have to be able to do this using our big kid math. So let's get ourselves some clean real estate to work on here, and my formula is going to say 75 degrees plus some unknown measure of x is going to equal to 90 degrees. We're going to use our algebraic processes to isolate the variable. We're going to subtract our 75 degrees from both sides. Those, of course, are going to zero out on the left, leaving x is equal to 15 degrees for our final answer. So we'll jump back over to here, and which one of these is it going to be? It's going to end up being B, because 15 degrees plus 75 degrees is equal to 90 degrees. Now we get to watch a nice little video about complementary angles.
You can use complementary angles to find an unknown value. Two angles are complementary if the sum of their measures is 90 degrees. Together, angle BAC and angle CAD form a right angle. A right angle measures 90 degrees, so angle BAC and angle CAD are complementary. Set the sum of the measures of the complementary angles equal to 90 degrees. Write an equation by substituting for each angle measure. The measure of angle BAC is given by the expression 9x. The measure of angle CAD is 36 degrees. The last step is to solve the equation to find the value of x. The value of x is 6.
So they've just shown you what I did in that previous problem. They set it up using an equation and isolated the variable. Only here their equation's a little more complicated than what I just did. What they did not do is give you the big kid algebraic work while they isolated the variable. You will have to do that on your homework and your test in order to get credit for them. And that leads us to example number 2, where they want us to take and find the value of x in this set of complementary angles. Of course, we can see it makes a right angle, so since it makes a right angle there, that little red square tells us it's a right angle. We know that the two of them added together is going to equal to 90 degrees. So we need to set up our formula. So I'm going to start off with the 28-degree angle right here. I'm going to add to that the 2x that's going to be right here, and those two angles together, they're going to equal to 90 degrees. Check it. That checks. Now I'm just kind of curious, what if instead I did the 2x right here plus the 28 degrees is equal to 90? It's the same thing really, and they're not going to let me check that answer for some reason because I reset it. I don't know. All right, let's keep moving here. From there, they took and actually did this way I did the second time, 2x plus 28 equal 90. They isolated their variable here using their big kid math. They subtracted 28 degrees from both sides, undoing addition and subtraction. Those zeroed out, leaving 2x was equal to 62, and then they divided 2 on both sides, undoing multiplication, and that left a final answer of x is equal to 31. They've got some great supporting work here. They wrote their equation, they isolated their variable the proper way, and now it's going to be your turn to do the same exact thing on extra example number 2. So pause the video and work this problem on your own. So what do I know here? I know that I've got two angles who add up to equal 90 degrees. We know they're going to equal 90 degrees because there's a red square here in the bottom, and that red spot means that it is going to be a right angle, and right angles are 90 degrees. From here, I'm going to write my equation. So my equation is going to start off with the first angle, which is going to give me 3x plus 9. Add to that the second angle, which is going to be 27, and all that combined is going to equal to 90. I'm going to simplify, combining my like terms, which is going to leave me 3x, 9 plus 27. That's going to equal to 36, and that, of course, all equals 90. Next, I'm going to undo addition and subtraction by subtracting 36 from both sides. These are going to zero each other out, leaving 3x is equal to, and that's going to be 54. And finally, we're going to undo multiplication and division by dividing both sides by the 3. These divide out becoming 1. 1 times x is x, and 3 is going to go into 54 18 times, I believe, if I did that math right in my head. Jump back over to the original problem. We do need to put in our formula, which is going to be 3x plus 9 plus 27 is equal to 90 degrees. Check that. That's our formula. And then we ended up getting 18 degrees for our final answer, which checks as well. Now the next concept we're going to learn are supplementary angles, which is very similar to complementary angles, except they add up to equal to 180 degrees. They make a straight line, so they're 180 degrees. If we look at it in words, the measure of angle 3 and angle 4 equals 180 degrees. And look at it with symbols, the measure of angle 3 plus the measure of angle 4 is still equal to 180 degrees. So for example 3, they're going to start off asking what the measure of the angle is that's supplementary to that. In other words, what angle plus 35 degrees, 135 degrees is going to equal to 180 degrees. They set up an equation that you can see. Let's say the sum of the measures of two supplementary angles is going to be 180 degrees. We'll put that in there. The equation was 135 degrees plus some unknown measure is equal to 180 degrees. They subtracted 135 degrees from both sides to isolate the variable, and that left the measure of the unknown angle as being 45 degrees. This is some really simple stuff, very similar to the complementary angles that we had just worked. From here, you get to do extra example number 3 on your own. So pause the video and work on this one. Make sure you're giving me good big kid math to provide a supporting work. So they want to know what angle added to 90 degrees is going to be supplementary or equal to 180 degrees. So setting up my problem, I'm going to say 90 degrees plus x is equal to 180 degrees, where x is what we're looking for. We're going to undo addition and subtraction by subtracting 90 degrees from both sides. When we do that, those 90s zero each other out, leaving x is equal to 90 degrees, so it's going to be another right angle. And yes, I do know y'all could have done that totally in your head and just looked at the answer key here and picked out, let's see, that's going to be option C for it, which would be the correct answer. But even if you can do it in your head, you still have to provide me with good big kid supporting work to justify your answers. And now we get another video, this one on solving supplementary angles, which is really what we just did.
You can use supplementary angles to find an unknown value. Two angles are supplementary if the sum of their measures is 180 degrees. Together, angle ADB and angle BDC form a straight angle. A straight angle measures 180 degrees, so angle ADB and angle BDC are supplementary. Set the sum of the measures of the supplementary angles equal to 180 degrees. Write an equation by substituting for each angle measure. The measure of angle ADB is 108 degrees. The measure of angle BDC is given by the expression 4x. The last step is to solve the equation to find the value of x. The value of x is 18.
Now don't forget, even though they didn't give you the big kid supporting work on how they isolated that variable, you will of course need to be able to do that on your test and on your homework if you want to get credit for doing it. That leads us into example number 4 that says write and solve an equation to find the value of x. Here we have this angle, 80 degrees, plus 10x come together to make a straight line. So since they make a straight line, we know that they're going to be equal to 180 degrees. So here we can take and set it up as the 10x plus the 80 degrees equals the 180 degrees. That checks. Then we're going to take and solve the equation, which they have the same thing I did. They undid addition and subtraction, subtracting 8 from both sides. Then that left them with 10x is equal to, I said subtracting 80 from both sides. That left them 10x is equal to 100 degrees. Then they undid multiplication and division by dividing 10 on both sides, and that left them with x is equal to 10, so the unknown measuring angle is going to be 10 degrees. From here, you get to do a problem on your own. Extra example 4, go ahead and pause the video and work on this one. So we know that these two angles coming together are going to add up to equal to 180 degrees because they do make a straight line. So let's take a look at how we're going to actually write our equation. I'm going to take the 8 times x right here, add to it the 116 degrees right here, and that's going to equal to the 180 degrees. Do I need to put that in here? What is the equation? Yep, so I had, what was it? 8x plus 116 equals 180. We're going to check that, and it checks. And now we need to solve to find out the value of x. To do that, we're going to isolate the variable, undoing addition and subtraction first. Minus 116 on both sides. These are going to zero out, leaving 8x is going to equal to 180 minus 116. Do some borrowing. That's going to give me a 4. 7 minus 1 is going to give me a 6. And then that 1 is going to zero each other out. So x is equal, 8x is equal to 64. Then we're going to undo multiplication and division by dividing 8 on both sides. And that, of course, is going to leave x is equal to 8. So 8 is going to be the unknown measure. Come back over here, type it in, and check. And our answer checks. With that, it is time for you to start your homework. Make sure you're giving me the same good, high-quality supporting work that I've been giving you on these problems, because if you don't, I can't give you credit for it. Good luck. I'll see you in class tomorrow.